Earlier this year in Davos, Switzerland, and just a couple of months ago at the World Economic Forum, we learned about the global disability crisis that's now plaguing us all around the world. This work was done by Caroline Casey, who is a legally blind innovator, and she brought to Davos the following information. There are about 1.2 billion people, or 20% of humanity, that is currently experiencing a disability. And collectively, this demographic faces a 50% unemployment rate, as well as a 50% poverty rate. That is 1 out of every 5 of us. That's a lot of people. That is more than the population of India, or more than the population of China, and 4 times the population of the United States. And our sponsor is Sir Richard Branson, as well as other folks. And in his words, he said, disability can no longer be a conversation for only health organizations and charities. It has to be positioned as a global business leadership agenda. So the question is, how do we tackle it? Now, when you drill down into disability, there are different aspects of it. For example, there's visual impairment. Visual impairment affects upwards of 600 million people who collectively around the world suffer a 90% illiteracy rate. At a time where information is very easily available at our fingertips, 9 out of 10 visually impaired people around the world are illiterate. And when it comes to unemployment per country, America is at 70%, the UK is at 75%, Mexico and Australia at 68%, South Africa is at 98%, and it just doesn't get any better than that. So this demographic faces a higher unemployment rate, as well as a higher poverty rate. And how do I know all of this? Well, I am visually impaired, even though it's very difficult for people to tell. Visual impairment doesn't mean it's totally dark and you don't see anything. Only about 5% of the world's visual impairment people actually face total blindness. Visual impairment is a series and layers of gray. I started my career in medicine. I left Nigeria, my home country, to go to America to study medicine. And I joined the US Army because I arrived like a typical immigrant with $200 in a duffel bag and quickly realized that we won't get that far. But within 2 years of my medical studies and military career, I was diagnosed with juvenile macular degeneration, specifically called Stargardt's. It just means that when I consume vitamin A, the excess is supposed to be flushed, but in my case, the protein responsible for flushing the excess is bad. So the excess sits on my macula, which sits on my retina, and it starts destroying the RPE layer, which is underneath the retina. The RPE layer contains the cone and rod cells responsible for all of our vision. Might be very difficult to understand, but think about when you do laundry and you fold it all up, then take a bottle of bleach and pour at the top, and imagine the bleach seeping through each layer and destroying things as it goes along. So that's what happens with Stargardt's. And it makes people become legally blind, meaning what the normal eyes can see from 20 feet away, even with my very best prescription glasses, I still have to walk up to the object from 1 foot away. So that's legal blindness. So after that, I tried engineering, but I kept struggling. And unknown to me, I had other eye problems. So 300 eye care doctors later, and 2 weeks at Johns Hopkins, we found out that I actually have 3 genetic disorders of the eyes. 2 genetic defects contribute to Stargardt's, and the third one contributes to cone rod dystrophy. So I literally won the lottery. I have 3 rare eye diseases. So I know a lot about this space. I'm also a disability advocate at the United States Congress, and I have spoken at the UN Social Goods Summit about disability. So this is something I'm very passionate about. Now, after learning all about the negative impact, I decided to turn my personal problem into a global solution. In other words, I decided to overcome my disability with creative abilities to tackle this problem. The biggest problem that the visually impaired faces is barriers caused by assistive technology. From the word assistive technology, it's supposed to assist. It's supposed to enable the disabled person cope with every single day tasks. For example, if I give you a business card, in 2 seconds, you will match my face with my name, email address, and phone number, and you're done. But if I got a business card from you, first I need to go get a handheld magnifier, and then I need to learn how to use it, and then I need to manually operate it. 2 hands are gone already. What if I needed to type? What if I were a student in school? What if I were at work? So it has limited functionality and diminished productivity, hence causing all of the high unemployment rates and high literacy rates. That is the outcome. So I came up with a way to, first of all, make it hands-free. Look, Ma, no hands. I really wanted my hands free, just like everybody else. I don't see anybody holding their eyeballs with one hand and operating them with the other. I want to be just like you guys. So I came up with a way that's hands-free and automated commands. And putting those together led me to invent something I call brain control for blind assistive technology. This is a way for people like me who are visually impaired to be able to look, think, and zoom to see better. Brain control. It makes sense. Now, how is this possible? Well, at the root of all of our emotions, our thoughts, our behavior, are these masses of neurons. They're like superhighways that talk to each other. And the way they talk to each other is through electrical impulses. So literally there's a lot of electrical impulses going on in your brain as you're looking at me. And by sheer technology of neuroscience and electroencephalography, or EEG, very similar to EKG, we are now able to leverage brainwave readers or EEG readers to tap this information. And the ingredient is this sensor right here. So when the sensor is touching my forehead, I can channel my thoughts through it. And then on my part, I've developed applications that go against it, that's able to allow me to use my thoughts to drive magnification and also to read things. So, how do you deploy cutting-edge technology to a demographic that can't afford it? I faced that challenge for a couple of years till I came up with something I called a social impact technology deployment model. And it goes like this. If you're trying to do some kind of social good that requires cutting-edge technology, first step is to connect it to a mainstream use case. Second thing is seek out non-diluted funding, government funding, philanthropic funding. Third is try to leverage tech transfer. Look for IP that's already available either via the government or through universities and colleges. And then also leverage the use of government-funded labs. By leveraging these steps, it will cut down the amount of capital you need to raise and make your job so much easier. So when it comes to thinking Zoom, I looked at an industry that's really growing and big enough. So the mainstream industry that we're leveraging is the video game industry. And why is that? Currently it's at almost $140 billion, and year to year it's growing at 13.3%. So it's a fast growing industry. And then when you look into its segmentations, there's a new segment called esports. These are those folks that you see either at a live conference or over ESPN, and you see two people just playing a game, just battling each other. Well, the highest earner just earned $1.6 million. So when your kids are playing games, don't say stop, encourage them. They can make $1 million just playing games. And then on top of that, huge companies like Google are now looking at no console gaming. They're trying to do away with the Microsoft Xboxes and Sony PlayStations. They want to stream games from the cloud like Netflix. So that's the future. So this is huge validation that the video gaming industry is a great opportunity to leverage for brain control. So what are we here today for? We're here at AI for Good, and this is Think and Zoom. And Think and Zoom is brain control solutions that is going to enhance the disabled with more productivity, as well as entertain the able with superpowers, with Magneto powers, with X-Men powers, with powers from Star Wars, so the Force may be with you. And here's a demonstration. What you're seeing is Kenti, K-E-N-T-I. It's in the Apple App Store. It won an award at Apple WWDC Worldwide Developer Conference in 2015. So we all know birds love to fly. They don't like to be trapped in a cage. But this one is trapped in a cage. Now, I am going to show you how I'm going to use my brain to free that bird. First, I'm going to put on the brainwave reader. And by simply thinking, I just free the bird through the use of my brainwaves. The hand is just showmanship. It's not necessary. And now that I'm done playing games, let's actually do some good work. So I'm going to show you the Think and Zoom application. Again, I'm going to use the same brain control methodology to drive visual augmentation.
Pressing visual no long drag.
And it reads as well. So, what do we want to do? We simply want to create a world where visual impairment no longer steals dreams or kills careers. We simply want to build an inclusive society where technology serves humanity rather than humanity being a slave to technology. Technology should not be used to cause division, whether across economic lines or other. Technology should be used to enhance humanity, to enhance our productivity, to boost our entertainment, and otherwise, we should use it to get to the next level, rather than using it to subject others below us. So that's what we want to achieve. A world where each and every single one of us will have the ability and opportunity to simply look, think, and zoom into their better, brighter future. Now, what are our next steps? Our next steps, we're looking for partnerships and collaborators. We're looking for people who are very well versed in AI. We're looking to leverage neuroscience and EEG, but simply treat it as data. So we're going to need machine learning. And by applying machine learning, the output will be very simple. For those who are vision impaired, we will ask them, simply think of 0 or 1. When you think about 0, you zoom in. When you think about 1, you zoom out. And if you're in a wheelchair and motor impaired, or mobility impaired, I'm sorry, well, when you think about 0, you can move forward. Think about 1, you can move backwards. And even for people with stroke, or ALS, or Parkinson's, or any kind of motor neuron impairment, for those people, the same methodology can increase volume, decrease volume, or change a channel, because they find it very difficult to simply pick up a remote control. So that's enhancing the disabled. And then when it comes to entertainment or boosting entertainment for the able, we simply give them brain control. While you're playing a game, say it's Mortal Kombat, and all you want to do is throw a punch, well, think of 0 and throw a punch. Or think of 1 and you can just jump. So we're trying to leverage cutting-edge technology for good, literally, to be able to offer the same solution of detection struggle and responding for the disabled, as well as intention detection and responding for the able. We can leverage the same brain control to serve everybody. So while here, if you're interested in partnering with us, our booth is right there around the corner. We'd love to talk with you. We're looking at neuroscientists, we're looking at data scientists, and also people very well versed in machine learning. And in closing, you can find us at www.thinkandzoom.com or www.zubyonwuta.com. And with your help and collaboration, we can build a world where we all can look, think, and zoom into our better, brighter future. Thank you.